Hi, my name is Steve Sanislow. How does electrical interference get into audio equipment? And more importantly, what can we do to eliminate it? Whenever a changing electrical signal moves through a wire, a portion of that signal radiates out from the wire and travels through the air. And whenever that radiated wave traveling through the air crosses the path of a wire, a small portion of it is converted back into an electrical signal that travels through the wire. We live in a world full of electrical wires carrying all kinds of signals, and every one of those wires radiates a small portion of its signal out into the environment. When these radiated signals get into our audio equipment, they get amplified into what we hear as noise, distortion, crosstalk, or hum. Some common sources of electrical noise include power lines, cell phones, computers, fluorescent lights, motors, and appliances. I'd like to digress a moment to talk about the early history of electrical noise. I hope that this will give you a better understanding of how electrical interference is generated. One of the first sources of man-made electrical interference was the cruise ship Titanic. It had a very powerful noise generator connected to a long wire antenna that ran the full length of the ship. Whenever the operator in the Titanic turned the noise source on or off, a signal would radiate out from this wire with the capability of traveling hundreds of miles. Other ships at sea also had long wires running from stem to stern. These wires were connected to very crude pieces of audio equipment. Whenever the Titanic generated an electrical noise signal that radiated out through the air, operators on other ships would hear static through their audio systems. By using Morse code, the operator on the Titanic could broadcast messages in the form of bursts of static. Now that we know a little bit about how electrical noise is generated and transmitted through air, let's take a look at a more familiar application. A musician with a guitar plugged into a practice amplifier. The sound coming out of the amplifier is clean, primarily due to the fact that the cable connecting the guitar to the amplifier is very short. Let's look at a similar setup, but this time there's a much longer cable connecting the guitar to a mixer. And to make matters worse, stage lighting behind the guitarist has a power cable running behind the guitarist parallel to the guitar cable to an electrical outlet. As you'd expect, interference from the power cable radiates out and is picked up by the guitar cable, and we hear it as hum coming out through the amplifier. You can still hear the guitar signal in the background, but it's swamped out and overwhelmed by the hum signal. So how do we eliminate the hum? The most obvious solution is to keep cable lengths as short as possible and to route them away from potential sources of electrical noise. But that's not always possible. We need a better way to cancel noise while preserving the desired signal, and the way to do that is through balanced audio. How does balanced audio work? Well, the laws of physics tell us that inverted and non-inverted audio signals will cancel each other out. But what exactly does that mean? I'll use the software program Audacity to demonstrate. On the top track, I've recorded a 60 Hz sine wave. And when we play it, it sounds like a hum. On the second track, I'll mute the first track. The second track, is an inverted version of the first track. And you can see on the first track when as the signal goes up and then down, on the second track the signal goes down and then up. When we play the second track, it still sounds like a hum. When we mix both tracks together, they cancel out into nothingness. Again, that's the first track by itself. The second track by itself, and when they're both played together, they cancel each other out. Now what I've done was I took the original guitar soundtrack, we can see it here, and in this case here I added the 60 cycle hum back into it. So it's a combination of both the guitar track with hum. And when I play it, you hear the guitar with the hum. Now on this track down here, I took the guitar track and added the inverted hum to it. And it doesn't sound any different. However, when I play both together, hum signals being out of phase, and one is inverted and they're both out of phase, they cancel each other out, leaving us with a clean guitar signal. So how can we put this theory into practice? We mute these signals here and go. Well, in practice, we take the signal from the guitar and we connect it to an active direct box. An active direct box is a device that converts a single-ended signal coming from the guitar into a copy of the original signal plus an inverted copy of the same signal. Now, as those signals travel down the length of the balanced line cable, they end up at the XLR connector of the mixer, where they're combined into a differential amplifier, which cancels out any hum and noise that might be induced over the length of the cable. So I hope this little demonstration sheds some light on how balanced line audio works. I invite you to ask me, email any questions or ask me questions in the forum, and I'll try to answer them for you. Thanks.